the sun can shine and heat tirelessly all year round. Because inside it, there's constantly occurring nuclear fusion reactions. However, its nuclear fuel will one day be exhausted. We know when a massive star evolves to the final moments of its life, it undergoes an incredibly violent explosion. This is what's called a supernova. The electromagnetic radiation produced in this process can even illuminate an entire galaxy, and it also releases gamma rays, X-rays, and high-energy particles, causing devastating damage to life on surrounding planetary worlds. As early as 1054 AD, ancient Chinese astronomer Yang Weidai witnessed an event of violent supernova activity. He observed a dazzling star suddenly appeared in the sky, and due to its extreme brightness, it was visible even during the day. It was then called the Emperor's Guest Star, and was meticulously recorded through modern telescope observations. It is indeed what we now know as the Crab Nebula. The Crab Nebula. According to calculations, only stars with a mass 8 times greater than the Sun will undergo a supernova explosion. When a massive star's nuclear fuel is nearly depleted, it first enters the red giant phase. Its volume rapidly expands. This is equivalent to the star, signaling its impending demise. After this phase ends, the entire star, due to the breaking of equilibrium forces, suffers an extremely violent explosion. The energy released equals the total energy the Sun emits in its lifetime. Simultaneously, it ejects vast amounts of material, including heavy elements, produced inside it, and its core will collapse into a neutron star, or a small black hole. If the supernova occurs within the Milky Way, in most cases, it's still visible to the naked eye. You'd see a sudden appearance in the sky of a twinkling light, lasting days to months. And the material ejected from such supernovae may eventually flow into interstellar space, driven by gravity, forming the next generation of new stars. For example, our Sunday is a second or third generation star. But for a low-mass star, like the Sun, a yellow dwarf, its ultimate fate in 5 billion years is not a supernova, but the formation of a typical planetary nebula. Nevertheless, Earth's position is relatively safe. Even the red supergiant star, Betelgeuse, which could explode any moment, is about 640 light-years away, far too distant to pose a substantial threat to Earth. So, in the long term, Earth needn't worry about external stellar influences, and we don't need to fear supernovae so much.